Good morning. Welcome to Too Old to Rodeo. Below the video is a link that you can click on and download an Excel spreadsheet I made for calculating both static and dynamic compression ratios. If you don't have Excel, there's a program called OpenOffice that you can download and install for free that can open Excel files. Also, there are a lot of websites where you can use their online compression ratio calculator for free. But what I found is I would get an idea and I would want to check something, and then I had to type in all the variables over again. So I wanted to create my own so I could save my variables and even save different versions and compare them. And whenever I had an idea, I could go in and tweak one number or another and see how that would affect the compression ratio on my engine. Compression ratio is very important when planning your engine build. Typically, the higher the compression ratio, the more powerful the engine is. But there's a limit to how high of a compression ratio you can have and still run pump gas and not be forced to run race gas. Whether you're using cast heads or aluminum, the size and shape of your combustion chamber, the piston material, the shape of the piston, your ignition timing, those all are factors in whether or not you'll be able to run pump gas on your engine. If you don't get everything correct, you risk detonation, which can damage and even destroy your engine. It's hard to find any definitive information on how far you can push compression ratio and still run pump gas. I've heard from sources I trust as low as 9.5 to 1 and as high as 10 3/4 to 1. And I'm sure there are others that think you can go even farther. When I first started planning my project, I was running right at 11.2 to 1, which was higher than I wanted. Some guys say that you can still run pump gas at 11.2 to 1, but you need to use octane booster. And I'm okay with using octane booster, carrying cans of octane booster with me as long as I can fill up at the pump. At one point I decided I was going to switch and run E85 in this engine, and then after doing research on E85 and how corrosive it is and how it tends to attract and draw moisture out of the air, I decided I really didn't want to run E85. So around here we have 91 octane, and if I can take 91 octane pump gas, add some octane booster to it, get it up to around 100 octane, then I'm good with that. The thing I'm having trouble finding is how much compression ratio can you run and how much timing can you run and not have detonation using 93 to 100 octane fuel. If you've got any information on that, I'd love to see it, and I'd love to know your source for it. I'm not an expert on this. I'm a noob. I'm not going to try to teach anything on compression ratio or give any advice on how high of a compression ratio you can run. What I will do is go through my spreadsheet, show you how I use it. I'll plug in the numbers for my old school stroker 383 build, and you can see that. If this is useful to you, I hope you'll subscribe to my channel and share it with your friends. Thanks a lot. Have a great day. Disclaimer: this compression ratio calculator was created for my own educational experience and use. I cannot be responsible for your use or misuse of it. It is provided free of charge, no warranty expressed or implied. Use at your own risk. An online search for compression ratio calculator will produce multiple sites created by professionals that can be used for free. I created this for my own use so I could save different configurations and compare them without having to type in all the variables each time. It also makes it easier to communicate with product suppliers. Use the Tab key to cycle through the input cells. If you do not understand what an input field is asking for or don't know how to get the input information, I suggest searching online for articles or videos that can give an in-depth explanation on calculating compression ratio. There's a lot of good information available, and I don't feel the need to duplicate it here. The intent of this video is to demonstrate how to use my compression ratio calculator spreadsheet. If you don't have the tools to accurately measure what is needed, much of this information can still be obtained for planning purposes from component manufacturers and your machine shop. Input your cylinder bore size in inches. My cylinder bore is 4.031 inches, 4 inches 31 thousandths. Then hit your tab key to move to the next input field. You can use the tab key to move through all the input fields one at a time. Input your piston skirt diameter in inches. Note, you must verify with your specific piston manufacturer the location where the piston skirt should be measured. My Wiseco pistons measured 4.026 inches at 1.3 inches below the bottom of the oil ring. Enter your rod length in inches. This is typically measured from the center line of the crankshaft bore to the center line of the wrist pin. I have 6-inch rods. Enter your stroke in inches. This is controlled by your crankshaft rod journal offset. The center line of the main journal to the center line of the rod journal is 1/2 of your stroke. The full stroke is when the rod journal moves from the 6 o'clock position to the 12 o'clock position. The stroke on my crankshaft is 3.75 inches. Input your cylinder head combustion chamber in cc, cubic centimeters. Note, cc and ml, milliliters, are equal. 64 cubic centimeters is equal to 64 milliliters. There are several good articles and videos available online that show how to cc the combustion chambers of your heads. The heads I am using have 64 cc combustion chambers. Input your piston effective dome volume. This information can come directly from your piston manufacturer. One thing to note is that different compression ratio calculators handle this number differently. Some want a dish piston volume entered as a positive number, and some will want that same volume entered as a negative number. It's very important that this and all of the inputs are entered correctly, or your resulting calculations will be wrong. My calculator requires that a dish piston or valve relief be entered as a positive number. The dish or the valve relief is adding volume to the total combustion chamber area. A dome piston volume would be entered as a negative number in my spreadsheet because it is making the total combustion area smaller. This is consistent with many online compression ratio calculators, but there are some calculators that reverse those numbers. They want the positive and negative reversed. It's very important that you know which way the calculator you are using wants the values and that you enter them correctly. My pistons have a 4.5 cc valve relief. I'm entering this as a positive number. The next entry is the deck clearance in inches. This is the distance from the top of the block down to the top of the piston, with the piston at top dead center. For some, this measurement may be 0. That is referred to as a 0 deck height. My pistons are supposed to be 10 thousandths down in the hole. I will measure and verify this during assembly, but for estimation purposes, I'm entering 0.010. Your compressed gasket thickness has to come from the manufacturer. There are a lot of different gasket thicknesses available. You can tweak your compression ratio a bit by adjusting the gasket thickness, choosing a thinner or thicker gasket. I am using 0.045 inches. I have a set of composite head gaskets of that thickness, although I'm not sure I'm going to use them. I'm considering using multi-layer steel gaskets instead, and may go with a different compressed thickness once everything has been measured during assembly. Your head gasket bore. Just like the cylinder has a bore, the head gasket also has a bore size. Often the head gasket bore is slightly larger than the cylinder bore. The bore size for the composite head gasket set that I have is 4.15 inches. The crevice height is the distance from the top of the piston down to the top of the first ring. The effect of this area may be minor, but if you really want to know exactly where you are as far as compression ratio, it should probably be entered. You can enter this as 0 to see how much it changes your compression ratio. Piston chamfer height and width. Here's a drawing to illustrate a chamfered piston. Not all pistons have a chamfer. Mine do not. These values can be left as 0 or entered to match your pistons. Enter the number of cylinders for your engine. Mine is a V8, so I am entering 8. The next two entries will come from your cam card. They can be verified with a degree wheel during assembly. My cam has an advertised duration at 50 thousandths lift of 231 degrees and an intake center line of 104 degrees. The maximum piston speed is determined by the material and the method used to manufacture your pistons. Cast and hypereutectic pistons typically should not exceed 4,000 feet per minute, while forged pistons may withstand up to 5,500 feet per minute. Note that these are maximum speeds that I found online and are to be used as estimates only. Do your own research and talk to your piston manufacturer to make sure your entries are correct for your application. This entry is used for calculating an engine's RPM redline. Remember, this is only an estimate of what the redline might be based on the piston material. Your valve train also plays a large part in how high your engine can rev. Hitting the tab key one more time will take you to the bottom of the page and show the results of your input. There's one more input field at the bottom of the page where you can give your input a name. You could enter something like Ford 302 option 1. I call mine the old school 383 stroker. The results. The piston to cylinder wall clearance is calculated based on the bore size and the piston skirt diameter entered. The total displacement of the engine is given in both cubic inches and in liters. Both the static and the dynamic compression ratios are calculated. An estimated RPM redline is shown. Your volumetric efficiency is calculated. A maximum required CFM for the engine is also shown. This can be used to help in choosing a carburetor or a throttle body. Remember, this is a tool for planning. How you use it correctly or incorrectly is up to you. I strongly suggest you run your input through multiple compression ratio calculators to verify your results. If you find this helpful, please leave a comment. If you have suggestions for updates or improvements to this spreadsheet, I would love to hear them. Please give this video a like, share it with your friends, subscribe to my channel, and click on the bell icon to receive notifications when I upload a new video. As always, I hope you have a great day and God bless.